a little bit of a head start, and you guys have been using the terminology of the discriminant really well already. So where's the discriminant found? Like, where's it come from?
Under the root sign?
It's under the root sign when you look at your quadratic formula. So put it in a sweet color. Now, if you remember, when we did the quadratic formula, I made you calculate the discriminant first. Remember when we were calculating things? Because it made it way easier in our calculator. So this thing in the green, the b squared minus 4ac, that's the formula for your discriminant. You won't be given it. Okay? You won't get given a formula of this is the discriminant, but it's right there. So you will be given the entire formula for the quadratic formula. You just need to know the discriminant's what's underneath the root sign. Today we're going to investigate what the discriminant does and why it actually matters to us. Some of that we've already talked about. So the discriminant is. So whatever numbers they were what, sorry? If they were
So like if B was 4 and A and C were both just 1.
yeah, it should be 12. Yep. And that's exactly what you do. You just figure it out and calculate it. So this is the discriminant. It's b squared minus 4ac. It comes right from the quadratic formula. Okay. The discriminant tells us something. So maybe we want to take a guess at what it could tell us. So if I told you, hey, the discriminant equals 10. What would that mean? If you could get this by just guessing, I'm going to be impressed. So I'll just give someone a chance if they want to try to guess what it means. Ready? If I told you what the discriminant was equal to, it tells you something. I'm just curious if anybody knows what.
Is it one of the intercepts?
Yeah, it's close. It's not one of the intercepts. It tells you how many intercepts you're going to have. So if I can tell you what the discriminant is, without calculating or solving anything, you can guess how many intercepts there will be. So I think this is actually, well, maybe I can erase it. Whoa. So the discriminant will tell you the number of solutions without actually having to calculate how many solutions there are. Remember, solutions are intercepts. Right? Solutions are x-intercepts. What's another word we might use? Roots. Perfect. What's another word we might use? Solutions. What's another word we might use? 4. Zeros. Awesome. So it tells you how many of those you're going to have. Those all mean the same thing. So how does it tell you that? Like, if you think about it, there's got to be a reason for why it can tell you that. So the reason how I know it's going to tell me how many solutions there are is based off of where the discriminant comes from. So where does the discriminant come from again? It's what's under the root sign. So if I told you the discriminant was -6, it's not possible. There'd be no solutions. You can't square root a negative number. That's how you could tell if there's no x-intercepts. Because if this was a negative number, well, then you can't square root a negative number. So the discriminant being negative means there's no solutions. We'll write that down. So we'll write down. What if the discriminant was equal to 100? Close. That's kind of the misconception. If I square rooted 100, that gives me 10. The quadratic formula has a plus-minus symbol. So there would be the plus 10 situation and the minus 10 situation. So how many solutions would there be? There'd be 2. So anytime there's a positive number under the root sign, you're going to have this plus whatever it was, this minus whatever it was, and it'll give you 2 solutions. Right? There's the plus situation and the minus situation. So that means if my discriminant was 2,000, there would be 2 x-intercepts. Because there'd be the plus situation, minus situation. If it was 0.05, then it would be 1 situation. If you added that 0.05, it'd be minus if you subtracted it. If it was 3.507%, don't know where I got that number from, just a random number, maybe it's their playoff chance. I don't know. But if it was 3.507, there would be the plus situation and there'd be the minus situation. There'd be two x-intercepts. No, there would be two still. So if it was 0.5, there would still be two. Yeah.
It doesn't come unless it's
Right. As long as it's positive, you'll always get two solutions. How could I get one solution?
Oh, if one of them equals 0, so if you get like a 6 in the one before the negative 6, then it equals 0.
If the discriminant equals 0, what's the square root of 0? 0. A number plus 0 is the same thing as a number minus 0. So if the discriminant equals 0, there would be one solution. Because adding 0 or subtracting 0 would be the same thing. So if I had, 9 minus 9, that's 0. Adding 0 and subtracting 0 would still give you the same answer. So, what the discriminant tells us. Okay, let's try this again. That was amazing. When we use the quadratic formula, if we're left with a negative under the root sign, that means there's no solutions. So a negative discriminant means there's no solution to that problem. There's no x-intercepts. There's no real roots. There's no zeros. Those terms all mean the same thing. What says here? Oh, no real roots. We already talked about it. So when a quadratic has no solutions, we say it has no real roots. So that's terminology you might need to hear. Or if I say no x-intercepts or no zeros, those are all the same terminology. It even says it at the bottom. Isn't that nice? Roots and zeros and x-intercepts and solutions, they're all the same.
So if there's no real x-intercepts, is that the same?
Yeah, that'd be the same thing. Now, we can describe numbers as being negative. Mathematically, what this means is that, do it in green, it means that b squared minus 4ac, that's the discriminant, if it was less than or equal to 0. Okay, that means negative. Do we see how that means negative? So that's the discriminant is less than 0. The discriminant is negative. That's a mathematical way that we could show that same thing. Alright. Determine the number of solutions. A quadratic can have 0, 1, or 2 solutions, as we've already discussed. So it's either going to have 0 solutions, or 0 roots, or 0 x-intercepts. It could have 1, or it could have 2. We can figure out if it has 0, 1, or 2 based on the discriminant alone. Whoa. Discriminant. So you can tell that just by looking at the discriminant. The way we represent it mathematically is in that little chart that you see there. The first spot in the chart, that represents the discriminant being negative. The second thing in the chart represents the discriminant being 0. And the bottom one in the chart represents being positive. That's how they mathematically could explain it to you. You see they've written a formula for the discriminant and they've used inequalities to express whether it's negative or positive or 0. So the first one is the discriminant is less than 0. That means negative. This one's the discriminant equals 0. And this one is the discriminant is greater than 0. And they've even told you right here, less than 0 means no solutions. Equal to 0 is one solution. Greater than 0 is two solutions. No matter what the number is, as long as it's greater than 0, it's two solutions. Do you know where those solutions are going to be? If I said the discriminant is 100, okay, that's positive. That means I have two solutions. Do I have any idea where they are? You don't. You have no clue. It's just telling you how many there are. So make that very clear. It's only telling you how many solutions. It's not telling you what the solution is. You would still have to do all the calculation to figure out what it actually is. Does that make sense? Yeah.
That's why I like quadratic formulas favorable to me.
Not really. It's why quadratic formula, why we calculate the discriminant first when simplifying. Like, the one reason is that it makes it easier to put in your calculator. The second reason is that it'll tell you right away if you need to do the whole thing or not. Because if the discriminant's negative, you can just stop, right, and you're good. You either made a mistake somewhere, or you're done the question. So that's why it could be kind of nice. You know, if you do box method, and you go all the way through box method to figure out there's no solutions, that can be kind of frustrating. So it can save you a little bit of time. Alright, how this could potentially look. Sometimes people have a tough time picturing this. So a quadratic creates something called a parabola. That's this shape right here. This is what no real roots would look like. No x-intercepts. This is what one real root would look like. It comes down, it touches, and it goes right back up. And this is what two roots could look like, just so you have some sort of idea. In the first one, there's no real root one. What's the discriminant of this thing? The discriminant of this equation. I don't know what it is, but I know something about it. It's negative. It's less than 0. Right? If I look at that thing, I'm not sure what the discriminant is, but I know it's less than 0. If I look at the second graph, what's the discriminant of the second graph? Never do that. It is 0, right? Because there's one solution. So the discriminant equals 0. And for two real roots, what's the discriminant on that thing? It's greater than 0. It's a positive number. I don't know what those numbers are. I just know that they're positive, negative, or 0. I'm going to keep driving that home because in a week when you guys have your unit test, there's a lot of times where people will be like, 1 x-intercept, the answer is 1. The discriminant must be 1. They connect the actual number with the discriminant, and that's not what it is. It's only positive, negative, or 0. The other thing that people make mistakes on is that, oh, there's two solutions, the discriminant equals 2. It doesn't mean anything. It's just positive, 0, or negative. Alright, using the discriminant. So we're going to use the discriminant to figure out how many solutions there are in these three. We'll do the first one together, the next two will be on your own. The first thing is remembering the discriminant formula. It's b squared minus 4ac. The values of b, a, and c, they come from something called general form. This is what general form looks like. So my suggestion to you is if you're trying to calculate the discriminant, you make sure you know what a, b, and c are. In this question, a equals 5, b equals negative 8, c equals positive 6. I want to figure out how many solutions there are to that quadratic. Just the number of solutions. So I'm going to put a, b, and c into my quadratic formula up here. When I do that, I use brackets. Makes a difference. So for b being negative 8, that be squared. I go negative 8 brackets minus 4 times a times c. Those brackets of the b squared make a difference. If you put negative 8 squared in your calculator without brackets, it'll say it's negative 64. If you put negative 8 in your calculator with brackets, it'll say it's positive 64. you want the positive answer, so you want to use brackets. So you calculate this thing, you're going to end up getting 64 minus 120. That means it's negative 56. How many solutions are there to that quadratic? There's 0 solutions. Very simple, right? Figure what A, B, C are, punch it in your formula, know what it means. I want you to try the next two on your own. I will write up my answer up the board in a minute, but I want you to try it fully on your own first. Forbidden. The first question. A equals 1. Right? If there's no A value, it's 1. It's 1x squared. The B value is negative 2. The C value is negative 3. Putting that in, that means I have negative 2 squared minus 4ac. If I was to calculate that thing, I'm going to have 4 plus, right, and minus saying a negative number, those negatives will cancel out. So 4 plus 12, and answer 16. How many solutions would I have? 2 solutions. The third one. I looked at that thing, and I wanted to calculate the discriminant. So I would go B equals negative 2, A equals 1, where I skip A, C equals 1, calculator, negative 2 squared minus 4, A, C, 1 and 1. That's 4 minus 4 is 0. Discriminant equals 0 means there's one solution. Everybody got that? Awesome. Things to remember. Make sure you have a negative in brackets if your B value is negative. That's probably the biggest thing people make a mistake on. The next thing people make a mistake on is you don't actually have to square root the discriminant to figure out the answer. Right? The discriminant is only with the thing underneath the root sign. It doesn't include the root sign. All right, we're going to talk about patterns for a second when it comes to the discriminant. So you don't need to write this down. It's not relevant to your world, but it might help you do a question really easily. So I'm going to add in a little page, just a blank page. Just to help you think. Right? This class is supposed to be about thinking. This is the discriminant. It comes from a quadratic. There's a really quick way to figure out if you're going to have two solutions. It's like a really quick way. Yeah, so you're 100% right. So I can tell right away if I have two solutions. I can't tell right away if I'm going to have 1. I can't tell right away if I'm going to have 0. But I can tell right away if I'm going to have 2. And the way I can tell right away is based on knowing that any number squared is always going to be positive. That's always going to be a positive number. Always. If this thing is a negative and I'm minusing a negative, that means I have a positive plus a positive. So how could I guarantee that this thing would work out to be a negative? If A and C were, sorry, ignore the subtraction sign. I want this to turn into a negative number. Because if you're minusing a negative, you're adding, right? Yes and no at the same time. Okay, yeah? One of them can be negative. If they're both negative, what happens? They would cancel it to be a positive. So this means if A or C is negative, you're good. The word or is not inclusive. So or normally would be inclusive. That's why I said yes and no. Because when you say or, that means both could be. This is or not inclusive. So that's different. Well, mathematically, when we say or, we talk about non-inclusive. So when you like, either would work. Yes. Yes and no. It's just how we use it. So, for instance, in like our regular world, in our regular speech, it's something or could mean both, or it could be different. So, for instance, if your parents were like, "You do your homework or you're grounded," those are two exclusive things. You either did your homework or you got grounded. You couldn't have both those things happen, like in that conversation. So yeah, those are non-inclusive or. Inclusive or could be like, you have a cat or a dog, but you could have both and you would still fall under a cat owner or a dog owner. That kind of see. So when we're talking about math, if you use the word or, we're talking non-inclusive or. At least for this sentence. Basically, either would work. Or if you want to just say A and C, this is how I would talk about it. A and C are opposites. You want opposite symbols for A and C. So if I looked at a question, and I said, x squared plus 2x minus 6, I know instantly there's two answers to that thing. Positive, negative, guaranteed two solutions. It's not something that you need to be able to calculate or write out or recite on a test or anything like that. But it could be something that maybe saves you a little bit of work one day. And you can look at a question and just know, oh yeah, there's two solutions to that. And I don't need to actually calculate my discriminant, because I just know. And it's just that thinking process, right? It's good for you. Another thinking question that you will need to be able to do is this. So I would star that for sure. Guaranteed to pop back up. It will be on your unit assignment if you already have it. There's a very good chance it winds up on a test. They give you a question. It says, determine the values of k for which the equation has two real roots. What does that mean, two real roots? It means the discriminant is positive. They just gave you something without actually giving it to you. So, they're saying they want this to happen. Right? That's what that means. The other thing is when it says determine the values, that means all values. So for instance, I could guess a value of k that would give me two solutions. I don't want to guess a value. I want to know every single value in the world, even if it's 0.303507. I don't know where I got that number from. Maybe it's playoff chances or something. But even if that's one of the answers, I want to know all of them. Okay? That's what that question's asking. See, that's what I like. I mean, so that could be some of the answers, but not all the answers. Like, for instance, I could look at this, and I know if A and C are opposites, I'd get two solutions. So K being negative would give me two solutions for sure. But is there a positive value for K that would also give me two solutions? That's where this all values thing becomes very important. So you need to figure out every single answer that gives you two real roots. That's what this question's asking. You don't know how to do that yet, and that's okay. But understanding what the question's asking is half the battle. When you see this on your assignment, people will write out answers. They'll say K equals 6 works. Oh, sure, K might equal 6, and that might work. They want all values that would make this work. Yeah.
I feel like K would equal 8 now.
Getting closer. Getting closer. So, if this is your discriminant, you want it greater than 0. What does B equal?
5.
B equals -5. What does A equal? Well, A equals 3. What does C equal?
No.
do know is k. So we could put those things in
And then rearrange.
and then rearrange it so k by itself. That's how you solve it. So you're going to put those values in as if you're calculating the discriminant, and you know you want that number to be greater than 0. If you look, you just created an equation with the k variable that's greater than 0. You need to solve this thing for k. And that'll tell you all the values that would work. Not just some, but every single one. How I would do this, I would figure out what this equals. And you had it right, what's the equal, Jess? So that's 25. The next thing I would do is I would multiply 4 and 3. So negative 12k. I want that to be greater than or equal to 0. That might seem silly to some people that I'm saying make sure you multiply those numbers together. Make sure you multiply those numbers together. So you got to figure out what the coefficient is. Now you just have to rearrange for k. There's 2 ways to do that. You can add 12k to the side and then divide by 12. Or what I think a lot of people would do, and it's because it's how you've been taught how to do it, is people would subtract 25 to the other side. How many people are like, yeah, I'd subtract 25 to the other side? Exactly, that's how you've been taught how to do it. So that's why it's what most of us would do. So we're going to do it that way. The reason we're going to do it that way instead of the other way is because there's going to be something that happens that we need to remember. So I'm going to minus 25 for both sides. That gives me negative 12k is greater than negative 25. My final step is to get k by itself. Sorry, I jumped from the left side to the right side. So I subtracted 25 from both sides. What's my last step to get k all by itself? Divide by negative 12. It is a negative 12 remaining.
Does not flip this.
What's it do, Jenica? You're right.
Flips this.
When you divide by a negative, it changes which way your inequality symbol is. So right now, my symbol is opening to the left. Because I divided by a negative, it switches. Negative 25 divided by negative 12 is 25 divided by 12. The negatives cancel each other. That is all the values of k that would work. As long as k is less than 25 over 12, then you are good. That is 100% something you need to be able to do. Yeah, or just one value. So people look at that question and they'll say k equals 3 would work. You're right, k equaling 3 would work, but we want to know all the values of k. So you need to have some sort of discriminant calculation like that. So if you went the other way, like if you solved it the other way. Yeah, so I'm just going to write it out here. So we had this. And as you get better at math, you get better at seeing things, right? So if I was to solve this question, I would have added 12k to the other side. Because I hate, one, doing extra steps, but I also hate dividing by negatives. Because it always screws us up. So that would give me 25 greater than 12k. When I divide by 12, I don't need to flip the sign because now it's a positive 12. And if you look, that's the same answer. Solved a different way. Right? That's why you could solve it another way too. It also helps explain why you have to flip the symbol when you divide by a negative. Because otherwise it wouldn't be right. Alright, this value that you've calculated is 25 over 12. It's kind of like a breaking point. So as long as k is less than that number, you're always going to have a positive solution. What do you think is going to happen when k actually equals 25 over 12? Yeah, somebody said it. Who said it? That's your exact moment it will give you 0 solution. Sorry, 0 as a discriminant. So this number I could use for more than one thing. If I wanted one real root, then I would say k equals 25 over 12. If I wanted 0 real roots, I would switch the sign around and now say k is bigger than 25 over 12. So this number is like a breaking point for you. If you're on one side of it, you're going to have two solutions. If you're on that number, you're going to have one solution. And if you're on the other side of that number, you're going to have no solutions. This number will always be that kind of middle ground in a question like this.
What if you didn't flip the signs and you had it the other way, but that kind of is confusing?
So like the way I have it right now?
Yeah, because it just sounds the other. Yeah.
Yep. Like those are the other way, right?
Yeah.
But is it pointing, both signs are pointing to which letter? They're both still pointing to the
No,
K,
I
right?
mean, like, because like when it says you have 0 solutions, it either is like with the one solution, so we have.
Yeah, here.
If it was the other way around,
I'm going to add a page and show you.
didn't divide by a
Yeah.
negative.
So if I had something like this,
Still.
I'm going to say, we were less than. That gave me two solutions. Okay. So if the question said, I want one solution, then k would equal 25 over 12. If the question said, I want 0 solutions, that would mean k is greater than 25 over 12. And you could reverse the way those, if the numbers were here and the k was there, then the sign would have to be pointed the other way. That doesn't answer your question at all. Okay, try again.
I just mean like, so you didn't divide by a negative number and the sign was still the other way,
Yep.
but it's still asking for two solutions. Does that still mean that you got two solutions?
Yep.
Because it's just the other way.
Yeah, that's fine. Like if you don't divide by a negative and the symbol stays,
Yeah.
then the question just, you're fine. You've done it, you're fine. And the question could stay the exact way you did it. So it's not always going to be greater than or less than. Like for a whole other question, this might be k is greater than this to give me two solutions. Just depends on the question.
Okay.
Yeah.
Otherwise, if it's greater than 25 over 12, it doesn't have any solutions, because it's still positive.
That is a positive number for k. But it turns the whole discriminant into a negative number. Remember what k is. K is my c value. So they're saying if k is a number bigger than 25 over 12, then the entire discriminant becomes a negative number. That's why it happens that way. Does that make sense? Because you're right, like we were saying positive, negatives, and it was getting a little confusing, right? And we're saying, how could k possibly be a positive number and I get 0 solutions? Like that doesn't make sense. But it's making the discriminant end up being negative. So a positive k value could still give you a negative discriminant. Yeah.
So it's not like talking about the actual discriminant, it's just talking about
Yes, this is just the actual k value. That's a good point. I promise you, this question will happen. You've been warned. There's a greater than 3.507% chance that this question happens. It's probably like the opposite. It'd be like 96.593% chance. That's the chance they miss the playoffs. Pretty high. Okay. This question could get harder. The way that they could make this question harder is instead of k, they could have made it k divided by 2. They could have made it k plus 6. Well, then your c value is just going to be some bigger binomial, and you're going to have to multiply things in and stuff like that. They could also make it harder by, in my opinion, instead of not giving you the c value, they could not give you the b value, which typically makes it harder because then you're square rooting to figure out what it has to be. So they could take away any of these three values. still do it. They can make the question really, really hard by taking away 2 of the values. I think that happens in your practice booklet as a challenge question. You won't see that on a test, as test 2. Pardon? If you were missing B and C values. So if you were missing both values, I'm just going to warn you what would happen. Probably not. I think it happens in your practice test. I got a really hard question that's trying to kind of push your knowledge. It doesn't happen on your test or a quiz. So don't panic too much about this. But if they took away your B and your C value, and you created this portion of the equation on the left, you could have a quadratic that's greater than 0. So then you'd have to solve the quadratic for being greater than 0. So then it would be mixing in your ability to factor and your ability to understand what numbers are doing. And it does make it a lot harder. It's like you're solving a quadratic to determine your discrete. It's kind of neat. That's why it doesn't happen. Except for like very challenging questions to see where you're at. Yep. You won't see that. You won't see something that crazy on a test. Any other questions? Okay, today you still have a good